Notch has an incredibly powerful particle system, and in fact it's one of our most popular features. In this chapter we'll learn how to emit, control and render particles. We'll look at creating particle systems using images, video and 3D space. We continue with our workshops in this chapter, so please follow along and learn as you go. Welcome to the particle chapter of this course. We will get started by adding 3 most important nodes for particles to run in Notch. And the first one will be particle root. You'll notice that there are several roots to choose from. So I'm going to go for particle root, the orange node. I'll connect it to the root of the scene. And now I need some kind of an emitter and some kind of a renderer. So I'll start with the primitive emitter. Again, a couple of choices that I named similar. So I want a particle primitive emitter. And the next node I will add will be a renderer. So in this case, let's go for point renderer. So if I hit space, I see my particles are working and spawning in the viewport. With that said, let's take a closer look at all 3 of these nodes and let's discuss some of the properties. So in a particle root, we can set a particle allowance. Basically, this is where we allocate compute power for Notch to generate those particles. So the default is 64,000. We can leave it at that. We will come back to this property a little bit later to talk about it a bit more. Then we have a pre-roll time, which is very handy, and we can make particles deterministic if we choose so. There are plenty of more properties, but at this point we're not changing anything here. So now let's move on to the primitive emitter. So primitive emitter is responsible for how does the particle spawn shape looks like. Primitive emitter is just one of many emitters we can take advantage of. We can use a mesh, image, spline emitter, but primitive emitter is just great for us to get started and talk about particles. So inside of the primitive emitter we have emitter types, and we can choose this to be a box, for instance, or a plane, but I think we can stick around with a sphere. So what else does the emitter do? Well, basically here you can set particle life. So the default is 5 seconds. We can set the particle number. So in this case, the max particle count is set to 30,000. So this is where it's important to come back now and to mention that this is where we allocate how many particles we are expecting to use. So we allocate compute power for 64,000, but in this specific case, we're only taking advantage of 30,000. And that's fine for now, but we can always increase or decrease this number as we progress. The most important thing is to make sure that the numbers in the emitter and in the root are rather similar. Right, next node we're going to talk about is the point renderer. So this defines how does the particle sprite look. So by default, point renderer is just a white little quad. And I think before we start making any changes to any parameters here, let's just make this sprite into a sphere. Now we could bring in a PNG file with the alpha or DDS, or we can just build a sprite ourselves by using generators. So I'm going to go for gradient. And I will connect to the first input of the point renderer. So it's working, that's great. So I'm going to shape it a little bit. First of all, we don't need that big of a resolution. So let's just set it 90 by 90. And I do want this radial. Inner range should be as big as possible. So 1. And I think this is pretty much good for us to work with. The only thing I don't like is this white outline. And to get rid of that, I can go to the blend modes and choose pre-mult blend. So this sprite already looks much better. Okay, what else can we do with the point renderer? Obviously, we can change the sprite, we can change the blend modes. Linear works for us just great. We don't need to do anything here now. And we can set the size randomness. Now, one note about size randomness. Anytime you exceed value of 1, you start to kill off the smallest particles in the viewport. So basically, you're rendering particles that are not visible in your viewport. So to avoid that, to achieve maximal randomness in size and not to kill off the particles, I would always suggest not to exceed the size of 0.9 in size randomness property. So the particles are definitely working, but they in no shape or form look interesting. So what makes particle systems interesting and animate and interact in all the crazy ways is effectors. And we have abundance of choices here. So I'll start with adding a turbulence affector. And as soon as I add the turbulence affector, I see that my particles start to animate. Maybe there's a property or two that we can change in the turbulence affector. First of all, we could have a little bit more velocity amount. So I'm going to set that to, well, let's give it an 8. And I see that the radius is rather big, so I'm going to decrease that. All right, that already looks a little bit more interesting. Can we add one more affector? Of course, we can use as many affectors as we want. So the next one I will add is going to be curl noise fluid affector from particles. There we go. Connecting that to the particle root as well. Now the very same shortcut that would connect nodes to the root of the scene, in this case, connects nodes to the particle root. So the shortcut Control R is root appropriate, root sensitive. So if it's a particle related node, we'll always connect to the particle root. So let's change some properties in the curl noise affector. Maybe the fluid simulation speed could be smaller. I would say significantly smaller. So maybe 0.03, something like that. We can always come back and tweak it a little bit more. We want something bigger in a curl noise amount. I'm going to go for something really big, like 190. It definitely changed the looks, but not to the better. But I'm pretty sure that if we make the size smaller, this all will start to look a little bit better. Maybe something here, around 0.15. There we go. This is much more interesting now. And I think I want way more particles in the scene. So in a primitive emitter, I'm going to bump these numbers up. Instead of the 30,000, I'm going to go for 250,000. There we go. Now, did the particle number count really went up? I really don't think so. That is because in a primitive emitter, we are requesting 250,000, but we're not allocating that in the root. So I'll come back to the particle root and I'll set that number to 250,000 as well. And now we definitely see an increase in particle numbers. So as mentioned before, it's important to keep these two digits similar. So this is where we set the compute allowance, and this is where we set the exact number of particles we want to use. So how can we make this setup a little bit more interesting? Just like with the effectors, we're not limited to 1 or 2. Actually, you can use as many as you want. Same goes with the renderer. So we can add another renderer. Perhaps a trail renderer. There we go. I'm connecting that to the particle root too. And I see that now we are drawing trails as well as points. Great. So what else can we do? Maybe a bit of shading could be fun. Just make sure to split these nodes up a little bit so we see it a little bit better. So here's our renderers, effectors, and an emitter. So let's start by adding something like live color shading. So live color shading allows you to choose 4 colors and they will span throughout the life of particle. So this is the birth and this is the death of particle. So let's maybe just set something of a likeness to a gradient. There we go. And the last color can be a little bit more different, maybe blue. So there we are. As particles are being born, they are reddish and then they go through the yellow and ends up being blue. So that too is not the only option. Of course, we can mix and blend shaders. I usually use just 1 or 2. Let me show you one more. So I'll disable the live color shader and I'm going to go for voxel cone shading. So voxel cone shading is a little bit more complex node to set up. So I'll start by connecting it to the particle root. Everything blacked out, that's expected. And for the voxel cone shading to actually work, we need 2 extra nodes. First of all, bound node and then a light. So let's start with the bounding box and we'll connect it to the first input. And preferably, I'll just kill it off for a second. We will make sure that the bounding box is as big or bigger than the current simulation that we are running. So let's make this bounding box 5 by 5 by 5. And I think that pretty much covers the space that we want to use. And now we need a light. So I'll just type in light. Grab that and connect it to the second input. So now if I position it to the side or above, you will see that this light is now working together with particle system and we are lighting it up. Why don't we increase the brightness a little bit? And we're not bound to just one light, so I'm going to make a copy, connect it to the same input, and perhaps push this very light to the opposing side. Might as well give it the color. There we go. Maybe the initial one could be a little bit darker, so we see a little bit more details. I start to like this. I start to like this a lot. So a little handy note if you're making an interactive setup or if you want the animation to follow the position of the primitive emitter. As you see now, both of the effectors actually exist in the center of the world. And if I start to change the position of the emitter, they haven't really moved. They are still there in the center of the world. Now, in a perfect case scenario, I want this animation to always exist and always work with the primitive emitter. And I can do that by connecting the effectors directly to the emitter. So now, should I move the emitter anywhere in a viewport, the curl noise and the turbulence actually follows that position. I'll put the emitter back to the 0 state. Now, just to mention, of course, you're not bound to just one emitter. You might as well have several. So if I bring in a new primitive emitter and connect it to the root, I see this emitter is working too. In this case, it doesn't have any motion or any animation because the two effectors that we have in the scene are connected directly to the first primitive emitter we made. So should we split them up? Then this emitter now has turbulence and this emitter has now curl noise. I'll put them a little bit aside so we see this a little bit better. Now, same goes for the shading. We can actually choose to use shading with a specific emitter if we want. And of course, we can connect renderers directly to emitters as well. But in our case, we're going to make do with just one emitter. And we will connect the voxel cone shading to the root as we had before. So I kind of like this simulation, but I would say that it's a little bit too fast. Now, of course, the natural thought process would be to perhaps slow down the effectors, but that would really change the way the particles looks. So in order to slow them down, we have a time stretch node. So I'll add that to the scene, connect it to the root, and then connect particles to the time stretch. So now I have all the opportunities to slow down the particle simulation without altering the effectors at all. I will set the time stretch to 1 just for a sec, so we come back to the default state that we had before. And let me draw your attention to the FPS count. Now, for the simulation to be consistent in the viewport and in a rendered video, should you choose to render it, I would always recommend that you limit or lock the FPS. So in this case, I have it already set to 25 by 25, and I will set it to limited. And notice how that changed the particle simulation. So when you work with particles, I would always recommend locking the simulation down to a specific FPS count for it to come out consistent in a viewport and in the rendered content. So now I can slow it down a little bit. There we go. And I think the trails are a little bit long. So in a trail renderer, I will choose the trail fade mode to length, and I'll reduce that length a little bit. There we go. I like this much, much more. So to make the scene a little bit more interesting and wrap it up, maybe I'll just add a camera and I'll make sure that we're spinning around this particle system. So let's get that done. So I'll add a null, connect it to the root. Now I will add a camera and connect that camera to the null. If If I hit 0, I'm looking through the camera, so I'll just pan out a little bit. There we go. And now I think I'm gonna need some kind of a modifier to spin around on the heading property. So I'm gonna go for continuous modifier. There we go. Let's connect that to the heading, and let's just make it faster. Maybe something like 35 would be good. In all fairness, those points probably could be bigger. So in the point renderer, I'm gonna make the particle size a tiniest bit bigger. And point renderer has a property for motion blur. So I'm gonna increase that to something like 2. That 2 helps here a little bit. And the orange light is very aggressive. So why don't we just reduce that a little bit? There we go. And to complete this, how about some post effects? Let's try to add some glow. There we go. Feel free to tweak this scene to your liking. Maybe change some colors, add more effectors. Perhaps even more lights, or some creative post effects. And once you're ready and done with this, let's head to the next workshop and let's talk about geometry-based particles, where we will be building something of a likeness to this scene right here. Okay, and if you're ready now, let's just make a new composition and let's build something of a likeness to this scene here. So new composition. I again need a particle root. I'll connect that to the scene root. We will go for the primitive emitter again. And we will need a trail renderer. Now I'm connecting that to the root. And notice if I hit space and try to simulate, nothing really happens. And that is because trail renderer doesn't really know where should it draw trails. For it to actually be able to draw trails, we need an effector in a scene. So as soon as we add something like Turbulence Affector, we will start to see those trails spawning. So let's change some properties in a Turbulence Affector. Just like in the previous scene, I think we would make do with a little bit more velocity. So maybe 13 here. Oh, and those particles are going so very far. So how about a smaller radius? Maybe something like this. Let's round it up, 3.8 for instance. And I think the particles are living a bit too long for what we need now. So in a primitive emitter, I will reduce the particle life. Let's say to 2 seconds. There we go. And I don't think we need that great many particles for the scene to run. So I will probably change this number from 30,000 to something like 8,000. Now remember, it's important to keep the numbers of the actual particles that we use in the scene and the compute that we allocate rather close. So I'm going to drop this down to 8,002. And while it's a little bit hard to read that we had a change in performance, when you're building out big scenes or you're using a GPU with a bit less compute power, matching up these numbers always increases the performance. So it's just a good practice to do the matching up always. Okay, what else can we do? First of all, let's add one more effector. How about that very same curl noise? I think that will vivid up the design a little bit more. So in a curl noise, we will change the simulation speed. I think we need less of that. So let's just start by 0.17. And we want a smaller radius. So maybe somewhere here. And we definitely want more curl noise amount. So I'll just bump it to something big like 300. And I start to like the shape of this simulation. So how do we now change it from the trails as sprites to actual geometry? So we can go for the primitive type and choose extruded geometry. And as soon as we do that, Now we are in the 3D world. So for this to be a little bit easier to read, I think I'm going to start by adding a standard renderer connected to the root of the scene. And of course we need some kind of a lighting. So I'll start with the skylight, environment image, and HDR, daylight HDR. There we go. So this starts to look much better. I'm not necessarily happy with the trails yet though, so I'll come back to the trails now and I'll make some changes. I think it would be nicer if this was, if the trails were a bit thicker. Yeah, this definitely looks better. So maybe something like 5. Let's just round it up a bit. And I would like them to be a bit shorter. So I'm going to switch from time to length. And I'm going to set it to something like, well, something around 1. There we go. This already looks better. I think this is where we can look into standard render and see if we can make some tweaks. Lighting. One thing we should definitely turn on here is ambient occlusion. And perhaps let's just shape it a little bit. I will do a little bit less distance here. And in general, I think these particles would make do with a little bit of color. So in the primitive emitter, I'll take advantage of the color control node. So I'm going to go for color ramp. And I can now choose how many colors I want to use with this ramp, but I think I'm pretty good with just 2 options here for now. So let's try something like deeper orange and some shade of blue. Not bad. Can we add more lights to make this a bit more exciting? Just make those oranges a bit brighter. And now I will add a spotlight. Let's push it here. Let's make it a bit brighter. So that gives a bit of a detail. How about omnis? Should we perhaps use omnis instead? Actually, I like omnis more. So I'll delete the spot and I'll make a copy of this omni. And I'll put it here somewhere towards the bottom. And I think it would be nice to have some motion. So just like previous time, I think I'm going to make a 3D null. I'll add a camera, connect it to this null, hit 0 to look through the camera. And now we'll give a little bit of animation to the null. So let's grab a continuous modifier. Straight away, let's make it faster because it's always a bit slow when it comes to rotations. And I will connect it to 2 properties. So heading and bank. There we go. Way more interesting. And trail renderer has actually an input for the materials. So we can try to add a material and see if we can tweak some parameters there. There we go. We can choose to make it brighter or darker. Actually, the thing that I really want to do is add a lot of roughness here because we don't need any specular highlights in this. Okay, cool. This is not bad, but again, just like previous time, I think it's just too fast. So time stretch in between the root and particle root will be just the property or just a node that I will need. Okay, there we go. This is looking much, much better now. And with this basic setup completed, we can work out some extras. We can add some post effects, we can change some lighting, we can even add some more effectors if we choose so. So how about some simple scattering for lighting? I just want to fill the background. And for this to work fine, I need a depth test enabled property to be ticked on, maybe the brightness a bit reduced. And I do in fact want a color here. So maybe something bluish. How about the very same glow? Would that help us here? There we go. Now I see that I have a LUT available for me, so I'll pull that into the scene as well. In fact, I can just go to my Essential Course Assets and Resources, and I can just choose to bring in all of the LUTs that I have available for me there. And is there anything else that we can take advantage of? Let's see, stills. I kind of like this element here. I'll grab that and I'll take advantage of that as well. So let's just cycle through the LUTs that we brought in and see if there's anything that works better for us for this scene. Yeah, we could even go for this one, for Hefe. But that would mean that the simple scattering now needs to be a little bit lighter. So I'll change that. And I think I'm going to add an image plane on this camera. I'll push it in the positive direction on the position Z value, and I'll grab that black and white circle center texture. Connect to the first input here. I see it's working. I do want this to be in additive mode, probably a little bit bigger. There we go. So this is becoming a little bit more interesting. How about one more image plane and some kind of a other texture to use with it? Let's say this UI code. Let's connect that. We do want this to be based in aspect base scale mode to a scale X. Maybe it's a little bit big. So let's just make it smaller. And let's just get rid of the information or texturing here in the center. So gradient. And it should be 1920 by 1080. And let's swap it to a radial. Let's just see how it looks. There we go. And of course it's doing the opposite of what we wanted, so let's just invert it. So for the good measure, I'll just add a point renderer here as well, because why not? Connect it to the root. Those points could be way bigger. And of course, it would be nice if they were circular. So gradient, generator. (90 by 90), and of course it should be radial. And the blend mode. I don't want those black outlines. It's not very visible here, which is fine. But I'm still gonna go for pre-mult. Now just notice another thing. We have a bit of a clipping here on the side. So if I preview, just for a sec, I'll set it to the default blend. It's very close here to the edges. I think I'm going to make the scale smaller. So 0.9 on all directions. And now we'll set it to pre-mult blend. Now it looks much better. We're not clipping the sides of the sprite. That's good. So in a point renderer, this could be in random size actually, and a wee bit smaller. And motion blur, that worked out for us last time really well. So I'll add that too. So again, play around, add post effects, add effectors, maybe shaders, anything you like to the scene. And once you're done experimenting, we should start looking into rendering particles using a video. So it would be a workshop where we end up with something similar to this scene right here. Okay, let's talk about particle effects for video. I'm gonna make a new composition. And I will start by adding a root. Point renderer will work well for us here. But now we'll grab Image Emitter. Now notice again we have two choices. Make sure to grab the particle one. So I'm adding that, and you will notice that it came in red, and that's totally fine. It's just indicating that it needs a little bit extra information to run. And that extra information comes in the shape of a video. So in my case, the video file that I'm planning to use is orange. If yours is marked up red, make sure to right click, go for Find Missing Resources, navigate to your asset folder, video, and relink it. So I'll grab this video, And I will connect it to the first input, Image Emitter. And as I do, I see that particles are definitely spawning and working with the video. However, they are not following the motion of the video. And our image emitter is a quad. We would definitely make do with the 16:9, because this video is 16:9. So let's start addressing these things. First of all, in the image emitter, I will change the scale X. I could do that by hand. Try my best to match up the 16:9 aspect ratio, or I can just type in 16 divided by 9, and Notch will do that for me. Great, so that's one thing out of the way. Now let's take care of the fact that particles are not following the video. So I'm gonna grab a couple of nodes. First of all, I'm gonna go for downsample and then optical flow. So we're gonna chain them up. I'm gonna connect a video loader to the downsample, and downsample does exactly what the name states. It just downsamples the resolution of the video. In this case, we don't need to downsample more than one iteration. So 960 by 540 is just fine to go to the optical flow. And optical flow is a technical tool that just reads previous frame and a current frame, compares them, and then where it sees a match, it attaches the particles. So in order for this to work, we're just going to connect it to the second input of the image emitter. Great, so this is working, but this is far from perfect. I would say we will change the pixel cull thickness mode from alpha channel to luminance, because, well, we don't have alpha channel for this video. That's already a little bit better, and we can always change alpha threshold. So maybe let's increase that. That's good. And I would say now it's a good time to perhaps look into a point renderer a little bit and make sure that that particle sprite is actually circular. So let's do the same thing as we did before. I'm gonna grab a gradient and I will pipe it to the first input. And now I'm gonna shape it a little bit. So I want this radial, I want inner range to be bigger, and I want this to be pre-mult blended. So let's see. Yep, this looks much better. In fact, we're doing this time and time again now. This is a good opportunity to mention that we can make presets in Node. So I can make a preset and call this particle sprite. So anytime I will bring in this gradient now, if I connect it to the first input here, I can go for the dropdown and choose particle sprite. There it is. I don't have to do it again. I can just choose it from the dropdown. Whenever you can, do use presets, especially if you're doing repetitive things. It's just gonna save time in the long run. So what else can we do here before we delve deeper to the design part of this? I think we need to add camera. So I'm connecting it to the root. I'll press 0 to look through the camera, and I could do my best to match the best position for it to fill the canvas, or I can do a little trick. So our zoom factor is set to 3.2. So I can actually copy this value, set -3.2, and then I'm sure that my position Z is correct to fill the available screen space. Good. So let's try to make this a little bit more interesting. First of all, those points are a little bit big, so maybe the particle size could be smaller. We could have a bit more size randomness in the particles as well. And just like before, we can use any and all effectors that we want. So how about that turbulence that we always use? So it is applicable. We could use it here. I don't know if it's the best choice, but I'm just saying that it's there. And any of the effectors that you want to use is good to go. But I think I'm going to go for field effector. So the name implies that it should work with the field system, and it has an input for the field node. However, in the context of video, we can use optical flow in the field input. And now we can choose to go for forces, and we can reduce those forces. So now when the particles are moving, they're actually moving with the velocity of the video. In fact, one more node would make do here. That would be velocity. I would like those particles to go downwards or give an impression that they go downwards. So let's move it down. Let's reduce the speed a little bit. Yeah, this starts to look like something. Should we have more particles? The image emitter could increase the numbers a little bit. That could be. I'm going to leave it at that for a sec. One thing that would help this setting is a little bit more readability. So all these things that we've discussed and learned in video processing, we can apply here. So I'm going to grab an image plane, connect it to the root, and mind you, stacking order is important here. So I'm going to put it in the back of it all. I will grab a video null, and I'll connect that base video together with the image plane, and I'll make sure that image plane is scaled correctly by aspect-based scaling mode scale X. So this definitely helps with readability, but we're losing a lot of small fun details. So what we could do is perhaps add some post effects here. How about some edge detect? There we go. Can we shape it a little bit? How about different mode? Yeah, that looks quite nice. Maybe something more, maybe vector blur, for instance. Yeah, we're getting somewhere. And I'm a fan of Kuwahara Filter, so let's add that here as well. Yeah, now we have more detail and we have particles. That's cool. We could have something in front of it all as well. So I'm gonna copy the image plane and video null and drop it in front. Again, stacking order is important. So now we're overwriting everything with this image plane in the front of it all. I think I'm gonna go for something like threshold, because I just want some details. I don't want everything, but I want just a bit of details of the highlights. And now in the image plane, I can choose another blend mode, like additive, for instance. Okay, cool. This is starting to look like something. I would say that this is a bit aggressive, this threshold. And how about if we use some Recolour here? So I'm adding that. And Recolour requires a color ramp, so I could bring it in, or I can just double click on this input and it will be offered for me. So let's do it from 3 colors. So the first one will be black. The second one could be deep orange, and the third could be lighter. Or actually, yeah, that's not bad. Let's leave it at that. What happens if we change blend mode of the Recolour? I think multiply looks quite nice. So for this to then make sense with the background, we might as well copy this and paste it here too. How about that? What if we change the stacking order? A little bit too much. Let's take it out. What if our image plane had a color? Yeah, just the tiniest shade towards the color of the foreground. And I think we would make do with Image Emitter actually having colors that fits this. So color ramp here. I'll connect it to the third input. And let's make it from, let's say, 3 colors. So from deep orange to lighter orange, almost yellow, and something crazy like blue. Well, there we go. Now it's becoming something. And of course, we have choices for what mode should it be in. So should it be emission time or input color? Maybe emission time would work for us here. Let's make this Recolour a bit lighter too. Or in fact, Why don't we just add one more? There we go. This is better. This is definitely better. And this is particles. Particles must have some glow. That's a law. So let's add some glow to the overall scene by connecting it to the root. Yeah, we're getting there. Maybe a little bit less blur and a little bit less softness. And we have a whole selection of LUTs. So why don't we try one of the LUTs here? Maybe that will help us here. Yeah, maybe this low Mo-Fi. Let's stick with that. Okay, let's add one more renderer. So the very same geometry connection renderer. Obviously, I do not want to see the drawn triangles, but let's try the lines. Let's use vertex colors. And let's just reduce the alpha threshold. In fact, we could use less particles. Cool. Look, we can go for days here. I think I'm going to leave you be to experiment more with this. By all means, try all of the available effectors and mix and blend those with all of the post effects that you find yourself enjoying so far. There is no right or wrong, there is just whatever you create. And since this is a real-time tool, you're not taxed with the render time, you just pick and choose things you like and you experiment and have fun.